Imagine trying to navigate a busy highway where hundreds of thousands of cars are zipping around, many of them driverless and without lights, moving at incredible speeds. Now, picture doing that in 3 dimensions, without sound or visible markers. This is the challenge facing us in Earth orbit, where countless pieces of space debris, often called space junk, pose a significant threat to our active satellites and spacecraft. Orbit determination for space junk is the precise process of calculating the current and future positions of these pieces of debris. It involves tracking them using various sensors, and then applying complex physics to predict their paths through space. This information is absolutely essential for keeping our vital satellites safe and ensuring the long-term sustainability of space activities. The core mechanism behind orbit determination is rooted in orbital mechanics and physics. Scientists and engineers use observations from ground-based radar systems, powerful optical telescopes, and even space-based sensors to gather data points on where a piece of debris is at specific times. Once they have enough data, they apply sophisticated mathematical models that account for various forces acting on the object. These forces include Earth's gravity, the gravitational pull from the Moon and the Sun, atmospheric drag, especially for objects in lower orbits, and even the subtle pressure from solar radiation. By understanding these influences, they can accurately estimate an object's current orbit and forecast its trajectory. So, how do we put this knowledge into practice? After determining an object's orbit, we can then predict where it will be in the coming hours, days, or even weeks. This allows operators of active satellites, like those providing your internet or weather forecasts, to perform evasive maneuvers if a collision risk is identified. It is like a cosmic air traffic control system, constantly monitoring and planning to avoid disastrous encounters. This proactive approach saves immensely valuable assets and prevents the creation of even more debris. One fascinating aspect is the sheer volume of data involved. Tracking agencies, like the United States Space Force, maintain catalogs of hundreds of thousands of objects larger than 10 centimeters, which is roughly 4 inches. For smaller pieces, estimated to number in the millions, they relying on statistical models and probability. The constant improvement in sensor technology and computational power is vital for refining these predictions, helping us to differentiate between objects and even identify the origin of new debris events, such as a satellite breakup or collision. Ultimately, orbit determination is our first line of defense against the growing problem of space junk. By accurately knowing where debris is and where it is headed, we can make informed decisions to protect our operational spacecraft, enable safe space exploration, and preserve Earth's orbital environment for future generations. It is a critical, ongoing effort that underpins everything we do in space.
Join us at Space Tech Insider, where innovation meets the infinite. Discover the future today.